All right, The Story of Life by Sherry Melanson. Chapter 1, What Are Little Atoms Made Of? Little atoms are made of, first, a thing called a proton. Secondly, a thing called a neutron. And thirdly, a thing called an electron. Every single atom in the entire universe is made of these three things, which makes it sort of simple for us. Go ahead and make a little chart here. We're going to make a chart. We're going to talk a little bit about these three particles. Oh, I keep tripping on the edge of my little rug there. So, I'm in a virtual reality space, if you can't tell. And in that virtual reality space, I have a little pad that keeps me from getting my feet all worn out. And when I step off the edge, I almost fall over. Alright, so we're going to talk about how much these things weigh. We are also going to talk about the charge on these particles. And we're going to talk about their location. All right, so let's review just a little bit. Every single atom in the entire planet is made of protons, neutrons, and electrons. All right, so protons have a weight of 1 atomic mass unit. Protons, 1 atomic mass unit, a charge of +1. And they are located in the nucleus or center of an atom. So I'm going to turn around here and I'm going to draw a proton right up here in the air. Single proton. All right. Neutrons weigh 1 atomic mass unit. They have no charge. And they are also located in the nucleus. Neutrons, 1 atomic mass unit, no charge, located in the nucleus of an atom, or rather in the center of an atom. Oh, I forgot to draw one before I change my brush. I'm going to go over here and I'm going to draw a neutron next to our proton. They're approximately the same size. Find my brush picker. All right, electrons weigh 0 That's 0 atomic mass units is 0 everything, really. I mean, it's 0. An electron has a charge of -1. And it is in orbit around the nucleus. All right, so let's draw an electron on our atom over here and make it complete, because what I have just given you is all of the parts of an atom. So if I just draw an electron orbiting around this thing, here we have an entire atom. And that brings us to another point, and that is that the identity of an atom is based on the number of protons that it has. All right, so you can see here our protons, 1 atomic mass unit located in the nucleus. The number of protons that an atom has determines what that atom is. And what I have drawn here is actually a thing called, oh, that is not what I'm looking for. Here we go. I have a media library here, and I have in it this little thing here. I'm going to put it right up above this. I'm going to get rid of this. All right, you see this hydrogen atom here? That number at the top, that 1, that tells you how many protons it has. That number at the bottom tells you how much it weighs in atomic mass units. And so this thing only weighs 1 atomic mass unit. So what the heck is going on here? What does that tell you about hydrogen? It tells you that on average, a hydrogen atom doesn't have a neutron in it. It just has 1 proton and no neutrons. So I can get this little eraser brush here, and I'm just going to erase the neutron out of here. And now we have an average hydrogen atom. You can have hydrogen atoms that have a second particle in the nucleus, but all hydrogen atoms have 1 proton. That's what makes them a hydrogen atom. Okay? So I'm going to introduce a couple of terms here. The first one I want to introduce is a isotope. Let's see. Isotopes. Oops, that is not the brush I want. I want this brush. Isotope. All it means if you say you have an isotope of something, this is an isotope, is that the number of protons the number of protons does not equal the number of neutrons. All right, so if I ask you, is this an isotope? You can say, yes, it is, because it doesn't have the same number of protons and neutrons. You could have a thing called deuterium, or heavy hydrogen, that has an atomic mass of 2. But on average, if you take a whole pile of these, it's a big specific number that you'll learn about when you take chemistry. So if you take a whole big pile of these, on average, they'll weigh this much. So most hydrogen atoms have just the 1 particle in the center. All right. The other thing I want to introduce you, a concept called an ion. An ion has an unequal number of protons and electrons. All right. This atom that I have drawn here is not an ion because it has one proton and one electron. This has a charge, if you remember, let's see, 2 of +1, and this has a charge of -1, and if you add +1 and -1 together, you get zero charge. And so ions have a charge. If they have more protons than electrons, they have a positive charge. If they have more electrons than protons, then they will have a negative charge. All right, I am going to erase this atom. All right, we can get rid of this, and we are going to draw another atom. Let's see. All right, I want us to draw, let's see, let's go with an oxygen atom. Oops. Well, that didn't work either. All right, hold on. I'll have this. There we go. All right, we're going to draw. Wow. There we go. We're going to draw an oxygen atom. All right, so I want you to look at this oxygen atom here. We have all the information that we need to know about it. That is that it has 8, see? 8, right here, 8. What are those? See if you can come up with it without me. That's right, protons. All right, how many neutrons do you think it has? Well, it weighs 16 on average. What is 16 minus 8? That's 8. That means that it's going to have 8 protons and 8 neutrons. It's not an isotope. And I'm going to go ahead and tell you that it's also not an ion, so it's going to have the same number of electrons as it does protons as well. So it's going to have 8 of everything. So let's go ahead and get our brush picker, pick the proton color here, and let's make our 8 protons. 1, 2, 3, 4, 5, 6, 7, 8. All right, brush picker. We're going to get some neutrons here. 1, 2, 3, 4, 5, 6, 7, 8. We have our nucleus finished. Now we want to do our electrons, and this is going to get kind of tricky actually, because I do need to introduce one more concept to you in this video. It's a simple concept, don't worry. The electrons. All right, electrons come in shells. All right, the outer shell, or sorry, the inner shell, the first shell holds 2. The next shell holds 8, and the next shell holds 8. There are other shells, but since this is just a basic biology class, we are not going to worry with the shells that go further out than this. You're just going to have to worry about the inner 3 shells. And they fill up, inner shell first, next shell fills up next, and then the next shell fills up after that. And so when we go to fill all of our electrons in, we're going to put 2 here. We have a total of 8 to fill, so we're going to put 2 here, and we're going to put 6 here. All right, so that's going to be pretty simple. So let's first of all, let's just draw our shells. I've been using the neon pulse, sorry, yeah, that's what it's called, neon pulse for the shells. So that's our inner shell that holds 2, and that is the next shell, which can hold up to 8. All right, we fill up inner shell first. And what I'm going to do is I'm going to go onto my brush picker here, and I'm going to pick a thing called light. I'm going to stay with green. And what we're going to do is we're going to put 1, 2 electrons in this shell. All right. Then we're going to fill this next one up. It holds a total of 8, right? We said it holds a total of 8. We're going to fill it like this. 1, 2, 3, 4, 5, 6, 7, 8. Until we have all of our electrons, all right? So 1, 2, 3, 4, 5, 6, 7, 8. All right, so I'm going to fill them on opposite sides, and you'll see why I do that at some point in the future. All right, so here we go. Here's our 2 outer shells. Now, in reality, when you have an atom, just put this label. We'll put the label right here. There we go. Isn't that beautiful? There's our oxygen atom. All right, so the reality is when you have an atom, the electrons are actually spinning around in a giant cloud. And so let's do the brush picker here, and let's look at what this would really look like. Okay, we would have our nucleus, and then around the nucleus, it would look like this, with like this cloud of electrons. You wouldn't be able to see even into the middle of it, and it's all going around like this. And so, you know, it's more complicated than our easy little diagram there, but that's okay. For our purposes, freshman biology, we're going to go with this. All right, so if I had something with 10, we would actually have 2 more here. If we had one with 11, we would have another one in another shell. If we had one with 12 protons, we'd have 2 in the next shell. But what if we had one with 6 protons? Then we would erase one of these and one of these, and then we just have 4 in the outer shell. So you can always build an atom if you know how many protons that atom has, all right? And if you try to break something down further than an element, what you end up with is something other than the matter that you started with. And so the element that we build with these atoms, we make these elements, they are the simplest form of matter. And so I've got one more picture for you here. Oops. Going to the wrong thing. All right, I have a periodic table here for you. All right. So I hope you can see that. This is a periodic table of the elements. I think I can resize it somehow. I'm actually not sure how. That's okay. We'll just get up really close. All right, you see that? That's hydrogen, 1. We're going to come over here. Helium, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you see how this works? There's room for 2 in the first shell. There's room for 8 in the second shell. There's room for 8 in the third shell. As you can guess, there's room for more in that fourth shell that we're not going to get to. But we can actually talk about life at the basic biology level simply using, oh look, I made it bigger. Here we go. All right, so we can talk about life simply using the first 3 rows at the basic biology level which is what this class is all about. So we're not going to worry about these additional things. And there are other things about this chart, obviously, but again, this is not a chemistry class, so we won't worry about that. We've got our basics. In our next class, what I'm going to do is I'm going to teach you how to bond elements together to make other things, to make molecules. Like we can make an H2O, which is a hydrogen and two oxygens. So we have two hydrogens and one oxygen. H2O, two hydrogens and one oxygen. And we'll show you how that works and how, you know, the number of electrons in the outer shell can make things bond together. We're going to talk about the three kinds of bonds. But that's just all spoiler stuff. All you need to know today, what are little atoms made of? Protons, neutrons, and electrons. Protons and neutrons each weigh 1 atomic mass unit, which is defined as the weight of a proton or a neutron, actually. So that's where the weight came from. Like, all you have to do is count the protons and neutrons, and that's the weight. All right? Protons, positive. Electrons, negative. Neutrons, big shocker here, those are neutral. And protons and neutrons, nucleus. Electrons, in orbit. Isotopes have unequal protons and neutrons. Ions have unequal protons and electrons, and therefore have a charge. All right, and that's it. I'm signing off for the day.